Welcome back, everyone. This video covers the Day 14 Coordinate Plane Test Review. Question number 1 says, calculate the slope of the line through point G, negative 9, 2, and point Q, negative 11, negative 8. The first thing you want to do to find the slope is to use the formula, and that is slope is y2 minus y1 divided by x2 minus x1. And of course, y2 is negative 8, y1 is 2, x2 is negative 11, and x1 is negative 9. Plugging in the numbers, we have negative 8 minus 2 on the top, negative 8 minus negative 9 on the bottom, and that comes out to be negative 10 divided by negative 2, which is 5. All right, number 2. What is the midpoint of the segment with endpoints G, negative 5, 4, negative 15, 4, and Q, which is negative 7, negative 12? Well, first, we'll need to use the midpoint formula, and that is x1 plus x2 over 2 for the x-coordinate, and y1 plus y2 over 2 for the y-coordinate. Plugging in the numbers, we have negative 15 plus negative 7 divided by 2, and 4 plus negative 12 divided by 2, and that comes out to be negative 22 over 2, negative 8 over 2, which is negative 11, negative 4. All right, number 3. It says if a segment has a midpoint of 3, negative 11, and one endpoint is negative 7, negative 5, find the other endpoint. First, let's label the endpoint, one of the endpoints, negative 7, negative 5. That would be x1, y1. Now, let's plug in the x1 into the midpoint formula along with the 3. So the 3 is the midpoint, the x-coordinate of the midpoint. So we would say 3 is equal to negative 7 plus x2 divided by 2. And if we multiply by 2 on both sides, that would give us 6 equals negative 7 plus x2, and then we would add 7 to the 6. So x2 would be 13. Likewise, negative 11 is the y-coordinate of the midpoint, and we set that equal to y1, which is negative 5, plus y2 divided by 2. If you multiply the negative 11 by 2, and then add 5, you'll get y2 is negative 17. And therefore, the other endpoint is x2, y2, or 13, negative 17. This is number 4. What is the length of GQ with endpoints G, negative 7, 2, and Q, 4, negative 5? First, let's label the points. x1, y1 will be the point G, and x2, y2 is point Q. We need the distance formula in order to find the length of GQ. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's plug in the numbers. We have the square root of 4 minus negative 7 squared plus negative 5 minus 2 all squared. That gives us the square root of negative 11 squared plus negative 7 squared, and that comes out to be the square root of 121 plus 49, which is the square root of 170. So that is the distance from G to Q. All right, here's number 5. On the coordinate grid of a map, Jeff's house is located at 19, negative 12, and Hannah's house is at negative 15, 24. Kenya's house is located at the midpoint between Jeff and Hannah's houses. What are the coordinates for Kenya's house? Well, first, let us label the coordinates. 19, negative 12 is x1, y1, and negative 15, 24 is x2, y2. Our midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. And here we're just plugging in the numbers for x1 and y1. And 19 plus negative 15 is 4 over 2. And negative 12 plus 24 is positive 12. And then when we divide each of these by 2, we end up with our answer 2, 6. That is the location of Kenya's house. Number 6. On the coordinate grid of a map, Josie's house is located at 6, -3. Her school is located at 7, -5. If each map unit equals 1 mile, what is the approximate distance from her house to school? Well, let's go ahead and label the points. So 6, -3 is x1, y1. 7, -5 is x2, y2. We're trying to find the distance, so we'll use the distance formula and plug in the numbers. So x2 is 7 and x1 is 6. 7 minus 6 squared. y2 minus y1 is the -5 minus -3, all squared. That comes out to be the square root of 1 squared plus -2 squared, which is 1 plus 4, and then our final answer is the square root of 5 miles. That is the distance from her house to the school. Number 7 says, is the following triangle a right triangle? Show work to prove your answer. Well, in order to do this, we're going to establish all 3 slopes and see if we have any opposite reciprocals. So here's the slope of PB. Slope of PB is, that's y2 minus y1 over x2 minus x1. That's 5 minus 8 divided by 3 square root of 3 minus 0. So we have that there, and that comes out to be -3 over 3 square root of 3. Next, let's find the slope of BJ. That would be 2 minus the 5 divided by 0 minus 3 radical 3. So that 2 minus 5 is 3, or -3, and then 0 minus 3 radical 3 is -3 radical 3, and then the negatives cancel each other. So this slope is 3 divided by 3 radical 3. And then we need to find the slope of PJ. That's y2 minus y1 over x2 minus x1. That's 2 minus 8 divided by 0 minus 0. And that's going to give us -6 over 0, which of course is undefined because you cannot divide by 0. Well, I don't see any slopes that are opposite reciprocals of each other. So then we can conclude that the triangle is not a right triangle. All right, for number 8, is the following triangle a right triangle? Again, show work to prove your answer. Well, first we'll find the slope of MN. That would be 2 minus -2 divided by 11 minus -1. And that's going to come out to be +4 divided by 12, which then reduces to 1/3. We'll also need to find the slope of NO, and that's going to be 6 minus 2 divided by the 5 minus 11. And that's going to come out to be 4 divided by -6, which reduces to -2/3. And finally, let's find the slope of MO. That would be 6 minus -2 divided by 5 minus -1. And that comes out to be 8 over 6, which reduces to 4 over 3. Once again, none of the slopes are opposite reciprocals, and therefore this is not a right triangle. Number 9. Given A, which is 2, 7, and C is -3, 6, find the coordinates of B that partition segment AC into AB and BC that have a 2:5 ratio. So we recognize 2:5 as being the ratio A to B. And the partition formula is x1 plus A divided by A plus B times x2 minus x1. That gives us the x-coordinate. And then the y-coordinate is y1 plus A over A plus B times y2 minus y1. We plug in the numbers. That's 2 plus 2 over 7 times -3 minus 2. That's our x-coordinate. And the y-coordinate will be 7 plus 2/7 times 6 minus 7. When we simplify it, again, best way to do that is just to plug this into the calculator. You get 4/7 for the x-coordinate and 47/7 for the y-coordinate. So this point is the point that partitions the segment into a ratio of 2:5. And here's number 10. Given point A, which is -4, 3, and point C is 1, 8, find the coordinates for B that partition segment AC into AB and BC that have a 1:3 ratio. All right. The 1:3 ratio is our A to B. And again, this is our partition formula. And we're plugging in the numbers into this partition formula. So it's -4 plus 1/4, 1 minus -4 for the x-coordinate. And the y-coordinate is 3 plus 1/4 of 8 minus 3. And if we plug all of this into the calculator, the x-coordinate is -11/4 and the y-coordinate is 17/4. So this is our partition point that partitions in the ratio of 1:3. And number 11, given point A, which is 6, -3, and C is 2, -8, find the coordinates of B that partition segment AC into AB and BC that have a 3:4 ratio. So the 3:4 ratio is our A to B, and again, this is the partition formula. We plug in the x1 is 6, and then x2 minus x1 is 2 minus 6. A over A plus B becomes 3/7. All right, that's our x-coordinate, and then the y-coordinate is the same with -3 plus 3/7 times -8 minus -3. And if you put all of this in the calculator, you get 30/7 for x and -36/7 for the y. So that is your partition point. Here's number 12. You're given a quadrilateral in the coordinate plane. Give all methods that you can use to prove the quadrilateral is a parallelogram. And there's actually 4 methods. Number 1, we can show that we have two pairs of parallel sides, and you would use the 4 slopes to show that. Number 2, you can show that the diagonals bisect each other, and you would do that by using the midpoint formula. Number 3, you can show that 2 pairs of sides are congruent, 2 pairs of congruent sides. You would do that by showing the 4 distances. And number 4, 1 pair of parallel and congruent sides. So that means you would do 2 slopes. You'd also do the 2 distances. All right, and that's number 12. And number 13, you're given a quadrilateral in the coordinate plane. What can you do to prove the quadrilateral is a trapezoid? Well, you need to prove that there is 1 pair of parallel sides, so you would need to show all 4 slopes. For number 14, you're given a quadrilateral in the coordinate plane. What can you do to prove the quadrilateral is a kite? You simply prove that you have 2 pairs of consecutive congruent sides. So you'd have to show all 4 distances. And of course, the 2 pairs of congruent sides, those are consecutive. They are not opposite. For number 15, assuming you know that you have a parallelogram in the coordinate plane, what 2 methods can be used to prove that you have a rectangle? Method 1, show that the sides are perpendicular, which means you'd have to show all 4 slopes. And number 2, show that the diagonals are congruent, which means you'd use the distance formula. Number 16, assuming you know that you have a parallelogram in the coordinate plane, what 2 methods can be used to prove you have a rhombus? Well, a rhombus is all 4 sides are congruent, so you'd have to show that. That's number 1. You do that by the distance formula. Or number 2, the diagonals of a rhombus are perpendicular, so you can show that using slopes. Number 17, assuming you know you have a trapezoid in the coordinate plane, what two methods can be used to prove the trapezoid is isosceles? Well, here you have an isosceles trapezoid, so you could show that these two legs are congruent. That's number 1, so you'd use the distance formula for that. Or number 2, you could show that these two red diagonals are also congruent, and you'd use the distance formula for that as well. Alright, for these next few problems, it says graph the given points on a coordinate plane and determine the type of quadrilateral. You must show work. Alright, so for number 18, we want to plot the points. So let's go ahead and do that. Alright, there are the points, and we've connected the dots to assume here that this is going to be a parallelogram. But we need to go through the steps to prove it. So first, let's look at the slope of AB and also the slope of DC. We see that they are the same, and it's actually -4/2, which reduces to -2/1. So those two sides are parallel. Next, let's look at the slope of AD compared to the slope of BC. And we see that those two are the same, and that slope is +4/3. So those two sides are parallel. And this is enough to prove that we have a parallelogram, and this parallelogram is not a rectangle because we do not have opposite reciprocal slopes. But we also have to show that it's not a rhombus. And one way to show that is to show that these diagonal slopes are not perpendicular to each other. So the slope of the diagonal AC is 0, and the slope of the diagonal BD is 8/1. So we see that these slopes are not opposite reciprocals, therefore they're not perpendicular, and therefore this is not a rhombus. Alright, for number 19, we have points P, Q, R, and S with these points given. Let's go ahead and plot these points. Alright, so P is at 4,8, Q is at 0,9, R is at -2,1, and S is at 2,0, and I went ahead and drew the diagonals as well. Alright, this looks like it could be a rectangle, but let's prove it. We'd have to show the slopes of RQ would be the same as the slope of SP, and they are the same, and it's 8/2, which is 4/1. Also, we need to show that slope of RS is the same as the slope of QP, and they are the same. It's -1/4. This is enough to prove that this is a rectangle because we do have 4/1 and -1/4, which are opposite reciprocals. So this is a rectangle. But this rectangle could be a rhombus or square, so we have to show that it's not that. So one way to do that is to look at the slope of the diagonal RP and compare it to the diagonal QS. The slope of RP is 7/6, whereas the slope of QS is -9/2. And we see that they are not opposite reciprocals, and therefore this is not a rhombus or a square. Here's number 20. We have points P, Q, R, and S. Let's plot them on the grid. And here we have looks like a parallelogram. Looks like it actually could even be a rhombus. I think it's a rhombus, so let's go for that. And I've also drawn these two diagonals here. Alright, so to prove it's a rhombus, we must show that all four sides are congruent. So if we look at the distance from R to Q, that's the square root of 7 squared plus 4 squared, because you go up 7 and over 4. But it's the same for QP. QP you go down 7 and over 4. In PS you go down 7 over 4. And SR you go up 7 over 4. So all four sides are congruent. It would be the square root of 7 squared plus 4 squared, which is the square root of 65. That proves that this is a rhombus. But now this rhombus could be a square, so we would have to show that it's not a square. To show that it's not a square, we look at the two diagonals. The length of the diagonal RP is 8, and the length of the diagonal QS is 14. That means it's not going to be a square, because in a square, the diagonals are congruent. Since the diagonals are not congruent, then we know it is not a square. All right, for number 21, we have points K, L, M, and N. Let's put those on the grid. All right, this appears to be a square. All right, so first we'll have to show that it's a rectangle using slopes. So the slope of MN is also equal to the slope of LK, which is -3/3 or -1/1. So we know that those two slopes are the same, MN and LK. And the slope of ML is up 3/3. Likewise, the slope of NK is up 3/3, so that's 3/3 or 1/1. Now we see that -1/1 and +1/1 are opposite reciprocals, and therefore this is a rectangle. So we definitely have a rectangle. But now we need to show that that it's not only a rectangle, but that it is a square. So one way to do that is to look at the slopes of these two diagonals, MK and LN. And we just need to show that they are perpendicular to each other. So the slope of MK is 0. The slope of LN, that's vertical, so it's undefined. And we know that a slope of 0 and a slope of undefined are perpendicular slopes. They're perpendicular to each other. Therefore, we do have a rhombus. And since we have a rhombus combined with a rectangle, then that means we have a square ultimately. All right. All right, for question 22 and 23, it says given 3 coordinates, find a 4th coordinate W that creates the indicated quadrilateral. So for number 22, we have points X, Y, and Z, and we want to form an isosceles trapezoid. So first, we plot the 3 points that we're given, X, Y, and Z, and we connect them. And so we'd have to have another point W, which I believe is going to be like right around in here. And I'm getting that because I see that to get from Y to X, I would go over 1 and up 3. So if I start at Z and I go down 1 and over 3, that puts me around this point here. So let's see what happens. So if we put a point here and then connect this point to Z and also connect this point to X, yes, then that looks like we have an isosceles trapezoid where XY and ZW are congruent. So W is this point here at 6, -4. Okay, for number 23, we want to show that this is going to be a parallelogram, so we would have to find the 4th point W to make it be a parallelogram. First, let's plot these points X, Y, and Z and connect them. All right, here's X, here's Y, here's Z. We want to make this a parallelogram. Well, the way to do that is to look at how to get from Y to Z. From Y to Z, you go up 1 and over 3. So, starting at X, go up 1 and over 3, and that's where point W will be. So there's your point. We'll call it W. Let's connect this point to x, and let's connect this point to the z, and yes, that looks like a parallelogram. And now we can call this point W, which is -2, 5. For number 24, it says graph the circles and identify the important characteristics. First, we see that because we have x plus 4 and y minus 2, that the center is actually -4, +2. Remember, the h and k is always the opposite of the signs that you see in the parentheses. The radius is the square root of 16, which is 4. Now we'll plot the center point, which is -4, 2. And that is here, -4, 2. And the radius is 4, so that means we'll go to the left 4, to the right 4, up 4, and down 4 from this center point. And we get these 4 corners of the circle, and now we can draw the circle. All right, for number 25, we have the equation as x minus 1 squared plus y squared equals 25. Because of the x minus 1, we know the x coordinate of the center is +1, and then we just have y squared, so that means the y coordinate of the center is 0. So putting that together, the center is +1, 0. The radius is the square root of 25, which is 5. So plotting the center point at 1, 0, and then going to the left 5, and up 5, and down 5, and to the right 5, we get these 4 points here, and then we can draw the circle. For number 26, it says find the equation of a circle whose center is at -2, 5, and goes through the point 3, 4. First, we'll write the circle equation, which is x minus h squared plus y minus k squared equals radius squared. Plugging in 3 and 4 for the x and y, plugging in -2 and 5 for our h and k, we get this next line here. That's 3 minus -2 squared plus 4 minus 5 all squared. And that's going to equal 5 squared plus -1 squared, which is 26. So 26 is the radius squared. And now we can write our equation. That's the x minus h squared plus y minus k squared equals radius squared. Comes out to be x plus 2 squared plus y minus 5 squared equals 26. And for number 27, find the equation of a circle whose center is 1, -3 and goes through the point -2, -1. We write our equation again, circle equation, and we plug in x and h and y and k. And the result is -3 squared plus 2 squared comes out to be 13. And so 13 is the radius squared. So now we can write our equation. That's x minus 1 squared plus y plus 3 squared equals 13. All right, for number 28, we want to write the equation of the circle in standard form and then identify the important characteristics. So in order to write number 28 in standard form, we have to collect a group of x terms together and a group of y terms together. And we also need to move this constant, number 7. That 7 needs to be moved to the right side. So we're going to subtract that. So after doing all that, we collect the x's together. That's x squared minus 6x plus some number, plus the group of y's, that's y squared plus 8y plus some number, equals, then we have the -7 that we subtracted, plus these two numbers here. Now we need to figure out what we're adding here. That's going to be 9, because we take half of the 6, which is 3, and square it. That would be 9. And we'll also have to add 9 over to the right side. Now half of 8 is 4, and 4 squared is 16, so we'll put 16 here, and then also add 16 to the other side. Next we will factor the x group. That would factor into x minus 3 squared. We would factor the y group. That becomes y plus 4 squared. And then if we add negative 7 plus 9 plus 16, we get 18. Now we can identify our center, which is going to be positive 3, comma, negative 4. So we write our center there, 3, negative 4. And the radius is going to be the square root of 18. And then the square root of 18, that simplifies into the square root of 9 times 2, which would then be 3 radical 2. All right, for number 29, we want to write this circle equation in standard form. So we'll collect the x's together and collect the y's together. Well, there's only one x term, and that is x squared, so that stands alone. Then we group the y squared plus 6y together, plus some number, and then equals some number here. All right, to figure out what we're adding to this space, half of 6 is 3, and 3 squared is 9. So we add 9 here, and also add 9 to the other side. Now we can factor this trinomial, and that's going to end up being y plus 3 quantity squared. We can also rewrite x squared as x minus 0 squared, and then we have plus y plus 3 squared equals 9. And now we can identify our center as being 0, comma, negative 3. So we have our center there. And then the radius is the square root of 9, which is 3. For number 30, we want to find the solutions to the system of equations. First, we use substitution by replacing the y in the circle equation with 3x minus 5. So we have x squared plus 3x minus 5 quantity squared equals 25. We can then expand the 3x minus 5 squared, and we get 9x squared minus 30x plus 25. Now we're going to collect the like terms by adding the 9x squared plus the x squared. And that's going to give us 10x squared. So we have 10x squared minus 30x. The 25's cancel each other because basically you're subtracting 25 from both sides. So this line we have 10x squared minus 30x equals 0. Now we can factor out what is common, and what's common would be 10x. So 10x comes out. That leaves us with x minus 3, and that is equal to 0. Now we're going to take the 10x and set it equal to 0, and x minus 3 also equals 0. And if 10x equals 0, then x is 0. If x minus 3 is 0, then x is 3. So we're going to have two solutions, both with x equals 0 and one with x equals 3. Now we need to plug in x equals 0 back into the y equals 3x minus 5 equation. And we'll also plug in x equals 3 into that equation. So if we plug in 0, we get y equals 3 times 0 minus 5 equals negative 5. And that yields the point 0, comma, negative 5. Now let's plug in the 3 into the equation. Y equals 3 times 3 minus 5, which is 4. And that yields the point 3, comma, negative 4. So these are our 2 points of intersection, 0, comma, negative 5, and 3, comma, negative 4. And for 31, to find the points of intersection is quite extensive because you've got these two circles here, and the answers are not very pretty at all, but I'm just going to walk through the steps really quickly, kind of skipping over a lot of the details. This purple writing is taking the top equation and expanding the binomials and writing it in general form. So this line right here is the first equation in general form. And then the blue writing is taking the second equation, the second circle, and expanding it and writing it in general form. And then here we take the two general forms of each circle, we combine them, we multiply the second equation by -1, so the x squareds and the y squareds cancel each other out. And you end up with -2x minus 8y plus 18 equals 0. That's a line. We just rearrange it to get the y by itself. So now we're here at y equals -2/8x plus 18/8. And that would reduce or simplify to y equals -1/4x plus 9/4. Now this is a line, and now we want to find the intersection of this line with one of the circles. And in this case, I'm using the first equation. So now we're finding the intersection of this line with this circle. And here's where it gets very intense in terms of the amount of work that is shown. But basically you're substituting -1/4x plus 9/4 in place of this y here in that equation. And this is what you get here. And you just add these like terms. And then there's just a whole bunch of other work that needs to take place. Like for instance here we're going to end up multiplying this line by 16 because we've got some fractions with 16 in it. And this actually is a 16 here. Okay, so that's actually 16 there. All right, we multiplied this whole line by 16 to get this line. Then we collected the like terms and set it equal to 0, so we end up with 17x squared minus 58x minus 71 equals 0. This is not factorable, so we have to solve using the quadratic formula. And after simplifying the quadratic formula, we have x is equal to 29 plus or minus 32 square root of 2 over 17. Now you have to plug that back into the linear equation to get y. So this is all of the work there. We plug that back into the -1/4 times x plus 9/4 equation. And you end up with 31 plus 8 square root of 2 over 17 for y. And then if you plug in 29 plus 32 square root of 2 over 17, you get 31 minus 8 square root of 2 over 17 for y. So these two highlighted ordered pairs are the solutions to the system of equations. And that concludes the video for the review of the Unit 3 test.